All right, so as mentioned, we are just doing some problems that have exponents on both sides. So think back to some problem, like this is what we solved, let's say, last week, right? And that's how you learn to first solve two-step equations, add this, divide by that. And then maybe short after that, all of a sudden they added like a variable over there as well. So if you know the structure of how to solve this, it's very similar to solving this, just variables on both sides. So our first goal is to get the variables to be on the same side, right? So if I can move this 3x over here, and then of course the second goal would be to get the numbers on the same side. So I'd add 1 to both sides. So that's kind of what we're going to do here at first. We just have to see, like, well, there's a 6 to x here, a 2 to x here. So I got to get these here on one side, and then the -2 part will be on the other side by itself. So just from the very beginning, it's good to understand where we're already heading before we even start, just to relate it to something we already know. Always a good way of learning something. So of course, since we have a variable in the exponent, that's what logarithms are for, right? So the first step is just to take the logarithm, and we're just going to do the common log, which is base 10, so we can use our calculators later on. Right. And what this allows, the function of log says, well, now that I'm using that, my exponents move down here. So this is the mechanism that gets those exponents out of there and down here, so we can solve it like a regular old linear equation, right? So now it's no longer an exponent, all right? It's just by itself. So we have x minus 2 log of 6 times x log of 2. Okay. Now I mentioned we need to get this 6 to the x and this 2 to the x together, right? Kind of like how I got these two together over here, right? Those are the ones we can combine together. So I have to break this thing up here. So in a way, it's not technically this, but this is what it looks like, is I have this log 6. Think of it as distributive property. Right, so I'm going to expand this out. So I have x times log of 6 minus 2 times log of 6. It's kind of weird how we're distributing with a number that's after the parentheses. Just pretend it's in the front, and it just, looks normal. And that's really one of the, logarithm properties here. And right-hand side stays the same. So you can see now we have, you want to look through and scan and ask yourself, what would go with what? Meaning which ones are variables and which ones are not. All right, so if I look at this, I can see, well, this has an x, so that can be combined with this. Right? And this is just a number, right? Minus 2 times log of 6, that's just a number. So it's kind of like this part over here where I'd combine just the numbers together. So they just, put them all on the correct side. And just like on a linear equation, you can put the variables on the left, the numbers on the right, or vice versa. It doesn't matter. Most people would probably put the variables on the left, even though it's a little bit longer, but that's what I'll do. So since this is a positive x, I'm subtracting x. Okay. And this is a number, so usually we add the numbers so they end up over here. So I'm going to add this to both sides. There's no number on the right hand side, so I just add it to 0 because there's nothing there already. So far, use a little bit of logarithm rules and the structure of solving a variables on both sides linear equation. Right? So like these would cancel out, these cancel out. Right? Those equal 0, right? And how 3x and minus 3x cancel out, these cancel out. So I have just this on the left side, variables which are on the left, numbers are on the right. Right? And then start putting them back together. Right? So we have, let's see here, we have x log of 6 minus x log of 2. I just rewrote these horizontally, so didn't combine anything yet. Right hand side, that was 0, so I just have the number 2 times the log of 6 Now we need to get x equals, right? Because on this one up here, 2x minus 3x, you just get negative 1x, right? And you have a single x. But right here, we still have two x's. So in the same way how we distributed in this log of 6 earlier, I'm going to anti-distribute or factor out the x. So I'm going to take the x out. All right? So I have an x, right? And then what's left over is log of 6 minus log of 2. This is what will give us having a single x so that later on we can get x equals. Right? So we need to go from having 2 of them down to 1. Right hand side stays the same. It's just a number. Now at this point we could just divide by this whole thing, log of 6 minus log of 2, and then just punch that whole thing in the calculator. Some like to shorten this, so you could look at this and say, follow this, like this equals log of 3. Okay. You remember why? On a Monday? Alright, so remember subtraction? Right? That we're subtracting two bases, which is the same as dividing. Right? So when you see subtracting, remember that's division. Right? So 6 divided by 2 equals 3. There we go. So I can just divide both sides by log of 3. It's just a number. Remember the answer to this is the exponent 10 to what power equals 3. That's what the answer to this is. It's just a number. And that would be the same as if I, over here, just divided by this number in front, which in this case would be negative 1. Right? Then I have x equals. That's what I just did here. I had log 3 times x. So I'm dividing by log 3 just to get 1x, right? Just like we always do. Only difference is that the number is after the x, not before, so it's a little different, but from this point, it's just a calculator problem. So you just turn that on, hit your fraction button, type everything in correctly. Oops. Try that again. Fraction 2. And we get the answer 3.2, or approximately 3.262. I still have mine on the float on 3 decimal places, or some calculators call the fix. So you fix it to that many decimal places. Definitely comes in handy. Now this is an equation. So much like you guys did back in the day, you were probably taught to check your answer. And you went back up to the original equation and you'd say, okay, x equals 9. You'd say, okay, 2 times negative 9 minus 1, and make sure that's the same thing as 8 plus 3 times negative 9. Right? You get the number on both sides the same, and you say, okay, it checks out, it works. So you could do the same thing here. This is a, still just a, an equation. So we can check it. So go off to the side and take your original equation, 6 to the 3.262 minus 2, and see if that's close to 2 to the 3.62. So I'd have 6 to the power of 1.626 I get about 9.595, and just see that if that's close enough to 2 to the 3.262. And sure enough, right? Notice how you have to use the approximate sign here because these last numbers are different. So since I'm using approximately, that's totally fine. We're not expecting it to be identical. All right. So give number 1 a shot. See how that goes. All right. I'll jot up the answer in a little bit, but you guys try it out. And then you can get started on the problems down here, and then all this fun stuff as well. Okay. Just a little bit of everything. And if you haven't finished something from the past, I highly suggest you get caught up on that and make sure you really know how to do those problems. Don't wait till the day before or the day of they're due. Right? It's not going to work out very well later on. So, did you catch on here how I got 25 over 11? So, do you see how I brought the 2 back up, made that 25, right? And then, of course, the subtraction is what makes it division. Right? Now, you could just divide both sides by 2 log 5 minus log 11, have a big old denominator. It's just a better practice to simplify things as much as possible before doing the division. And always save your estimations or your calculations for the very last step. So you notice on all these, I do this whole thing, and then one time at the end I put in everything, I hit enter. I say that because some people up here might say, well, what's that decimal? And then, oh, what's log of 25 decimal? What's, log of 11 decimal? And they have a decimal divided by a decimal, and then your margin of error, your approximation, is now even less accurate because you're rounding twice and then dividing those 2 rounded numbers and getting another rounded number. So the number of rounds, as the number of rounds goes up, the accuracy goes down. So we always wait till as late as possible to get one single calculation, right? So during your quizzes, right, you should be using it one time per problem at the very end, right? It's not like you're going back and forth from your paper to your problems over and over in the same thing. Okay, just one swoop. Okay, all right, that's about it. So you got lots of time to ask lots of questions on pretty much anything you need help on, so that in a few days you're all ready to do this by yourself. Okay.